Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Thank you very much for the attentions. My name is Nuraini Lucy from Department of Mechanical Engineering, Polytechnic Negeri Banyuwangi. In this time, I would present my research with the title Applications of Taguchi and Gray Relational Analysis for Parametric Optimizations of End Milling Process of Asset XW42. One of the milling processes that are widely used in the manufacturing industries such as steel and plastic molding, automotive and aircraft industries is the end milling process. End milling process is used to produce a workpiece with a flat surface, profile, radius, pockets, and groove. Some of the challenges in the manufacturing industries are how to achieve higher material removal rates and better product quality with a good surface roughness. In typical manufacturing process, both are influenced by the cutting speeds, feeding, and depth of cut. Specifically, increasing both parameters will yield higher material removal rates, lower surface roughness, heat generated by frictions in the cutting zone. Both the generated heat and the frictions are commonly reduced by applying cutting fluids, which are also used to reduce friction coefficients and clean the chips. Surface roughness has the smaller the better quality characteristics, while the material removal rates has the larger the better quality characteristics. Therefore, the combinations of process parameters need to be properly selected regarding the machining tool and material properties in order to minimize surface roughness and also to simultaneously maximize the material removal rates. The multiple performance characteristics could be achieved by determining the optimal parameters using the multiple performance characteristics optimization method. In this research, multiple performance or quality characteristics optimizations method developed based on statistics optimizations. The Taguchi methods combined with Gray relational analysis to explore the relationships between machinings or explanatory process parameter and performance characteristics or response variable as well as to predict the response. The purpose of this research is to determine the setting combinations of cutting fluid, cutting speed, feeding speed, and depth of cut, which yields minimum surface roughness and maximum material removal rate. The process parameters used in this research are shown in the table. As we can see that each process variables or each process parameter has a true level and the other process parameters consisting of 3 levels. The response variables in this research are arithmetic surface roughness and material removal rate. The table performed the orthogonal array that used for the experiments and led to a total 18 tests. A L18 orthogonal array has been selected based on Taguchi quality design concept for the experimentation's purpose. In this research, the interactions effects of machining's parameter has been assumed to be negligible. The workpiece used in this study is ASAP's XW42 tool steel material with the dimensions. The width is 30 millimeters and the length is 80 millimeters, and the hardness of this workpiece is 45 hardness Rockwell C. The cutting tool used is a solid carbide end mill with 4 cutting edges with the diameter of 10 mm and the overall length of 75 mm. Here the steps of Taguchi Gray Relational Analysis Optimization method. The first step is calculations of the SN ratio. Signal to noise or SN ratio transform the data of experiments into a value that represents the variations and average value of the response relative to the standard deviations. Based on the types of characteristics, there are two different types of SN ratios. Since material removal rate is larger the better and the surface roughness is smaller the better. The next step is normalization's SN ratio of each response. In the multi-response optimization techniques, signal-to-noise ratio data must be normalized. Normalizations is essential to make the SN ratio data dimensionless and unitless in order to make a proportionate comparisons. The SN ratio have been converted into value in 0 to 1 interval by using linear normalizations, and this is the results of normalization SN ratio, which determined by using the equations. The next step is determinations the value of deviation sequence and calculations of Gray relational coefficients. Gray relational coefficients is applied for measuring multiple response relevance. The relations among the actual conditions and the ideal conditions of the normalized response is shown by GRC value, and the calculations of GRC is conducted by using these equations. The next step is calculations of GRG or Gray relational grade. GRG is represent the degree of correlations between the reference and comparability sequence. In case of two identical sequences, the Gray relational grade is equal to 1. The next step is performing statistical analysis of variance or ANOVA. The purpose of ANOVA is to identify which machining's parameters significantly affecting the machining's performance characteristics, and also obtaining quantitative estimates of the contributions of each factor to all responses. Based on the tables, the contributions of machining parameter in order are feeding, depth of cut, cutting speed, and cutting fluid. The last step is determining the combinations of process variables for optimum response. The figure performs ratio plot of GRG. In this plot graph clearly mentions that the optimal combinations of process parameters for multiple performance characteristics are first level of cutting fluid, first level of cutting speed, third level of feeding speed, and third level of depth of cut. Based on the experimental results and optimization process, we can conclude that combination setting for milling process parameter that can minimize surface roughness as well as maximizing material removal rate simultaneously are as follows. Type of cutting fluid is soluble oil, cutting speeds of 5.6 meter per minute, feeding motions of 111.9 mm per revolution, cutting depth of 0.5 millimeters. And this is the end of the presentations. Thank you very much for the attention. Assalamualaikum warahmatullahi wabarakatuh.